All right, good morning, and some quick reminders. Your lab number 4 will be due this week, and as I mentioned before, your lab number 4 is going to be the basis for your programming test number 3. For programming test number 3, which will happen in about 2 weeks' time. And for tomorrow, the scheduled lab session, there's nothing scheduled for you to really show up, but if you want to discuss your solution about lab number 4, I will be there and the TA will be there, optional if you want to. Okay, so tomorrow, okay, if you want to discuss. And your written test number 3 and also programming test 3 will still following the semester calendar quite faithfully, so just check the dates. And I'll reach out to you about practice question for written test number 3, maybe after Wednesday, so you definitely got time. But it wouldn't hurt to really start reviewing the materials about inheritance, for sure, and maybe aggregation composition as well. All right, and let's now get to typecasting, okay? So I would like to maybe do a recap by using an example, right? So far, we actually cover many small topics about inheritance. They should all connect together. You will always be given some inheritance hierarchy, and of course, given the Java class declaration, you should really try to draw a diagram like this. You will have some small exercise to do today after the recap, briefly. So given the hierarchy of certain classes, you have certain lines of code that you have to analyze. And you have to sometimes judge only based on static types. And sometimes you may have to take into account dynamic types as well. Let's recap very quickly about these 3 lines. I think they're quite typical. Line number 1, we declare some variable over here with some certain static type. And we are trying to assign the very first dynamic type for this particular variable, right? Let's just try to recall all the terminology over here. So this smartphone over here would be the static type. And this Samsung over here would be the very first dynamic type. It may be changed later, as often as you like. And then you can look at this line over here. We are still trying to do a variable assignments here. But now the extra complication is we are trying to cast the reference variable into a particular class type. And we spoke about last time. If you want the cast to be compilable, you can either do upward casting to some ancestor, or you can do downward casting to some descendants, right? So here, I would like to point out 3 things that you really want to make sure you actually get. Number 1, you want to make sure you understand whether or not this particular variable assignment should be compiling, right? To really judge this one here, you want to make sure the dynamic type over here is a descendants of the static type, in which case it is. Let's just draw that very quickly. Smartphone is the static type over here. And also Samsung dynamic type is over here. As long as it is a descendant of that, then we are okay, because this can fulfill its expectation. All good. And we talk about cast. So there are 2 lines you want to watch out for, 2 parts. One part is about just the cast. About the cast over here, there are 2 things you want to think about. Number 1, there's a compile. And number 2, there's a run into class cast exception. So these are 2 orthogonal, well, they're somehow related. Let me explain that in a moment. Class cast exception. These are the 2 things you want to always consider. In order for number 1 to be satisfied, as long as you're doing an upward cast or downward cast, it will compile. And whenever you're discussing whether or not the class cast exception should occur, you're already assuming that the cast already compiles. If it doesn't compile, you don't even execute the code, right? So these are the 2 questions you want to think about. I'll get to that in a moment. And you can see here, we are trying to cast into Galaxy S21 Plus. Let's highlight that as well. Let me use blue. So you can look at Galaxy S21 Plus. So now we got 3 classes in the hierarchy that we have to think about, right? Number 1, we have static type. Number 2, we have dynamic type. And number 3, we have the cast type. Now, is this a compilable cast? To cast from static type here to here? It is OK, because it's downward cast, right? Let me just, number one is actually OK. It's a downward cast. And number two is a little bit tricky. Is this going to run into a class cast exception? If so, why? Anybody want to try? Before I give you guys some hints. Maybe some hints. In order to judge whether or not a class cast exception should occur, you ask yourself this question. Oh, by the way, class cast exception is a runtime phenomenon. So that means you have to bring the dynamic type into play. Okay? You just ask the simple question. Can the dynamic type fulfill the cast type? That's the simple question you're going to ask. So we talk about dynamic type and also the cast type. Diagrammatically, can this Samsung over here fulfill the expectation of the Galaxy S21 Plus? No, actually it cannot, because this is not a descendant class of that. All right, guys, be careful. Let me just write it down. Can dynamic type fulfill the cast type? That's a question. The answer is no, because dynamic type is not a descendant of the cast type. All right, guys, I'll pause for a moment. We're still recapping, right? Any question up to now, if there's anywhere that you don't find very clear, it's now the time to ask before I try to show you some more general summary. Marcus, are you okay? Okay, good. I want to make sure. All right, but think about the issue. You still have time before next Tuesday. Okay. All right, so that's about the class cast exception. And of course, there's one more thing. Don't forget, if you want to judge whether or not this particular variable assignment here should really compile, what should you look at? This one here, you want to look at what's really the static type on the right-hand side. As we said before, since we are trying to cast into this particular type, we're only talking about compilation. We're asking whether this is a descendant class of that. It is, so that's okay. Okay, so this one compiles because the cast type, which is over here, is a descendant of the static type, which is over here on the left-hand side. Are we okay so far? Okay, let me make one small connection to what we're going to talk about later after I do some summary. You can see that in order, for a class cast exception to really occur, that occur when the dynamic type cannot really fulfill the expectation of the cast type. That's precisely the condition. Wouldn't it be nice for us to do some check on our own as a programmer to say if the dynamic type can actually fulfill the cast type, and then we do the cast? There is such an operator called instanceof, which we'll do later. So here, let me make one more connection, and then I'll move on to some general summary. So can dynamic type fulfill, okay? And this can be done, this can be checked by the so-called instanceof operator, which I will get into in a bit. So there's another keyword for you to know, instanceof. All right, we'll get there. Don't worry. I just want to make some connection. All right, so if you look at the slides, what we just walked through was about slide 63. All right, so everything has been set already. You can definitely look at them just for the written form. And also, there's another example over here, which is very similar. And for that one there, I just want to show to you how you can visualize it. You can see here, we got, again, the three types. Smartphone over here, static type. And also here you can see Samsung, which is over here. That's the dynamic type. And over here, we are trying to cast that into iPhone 13 Pro. iPhone 13 Pro, that's the cast type. Right? To really cast from here to here, it will compile. It's a downward cast. But is it going to run into class cast exception? It is, because dynamic type here is not a descendant class of the cast type. Right? You see, diagrammatically, it makes more sense. But always think in terms of expectation. I think that will definitely help. All right, let's now do a summary to conclude just about the casting part. And then we're going to see a new operator to help us further. Given any hierarchy, for example, like a smartphone over here, okay? Let's say you have some reference variable declared to be of certain static type and has certain dynamic type at the moment. Okay, let's now visualize it. So first of all, we got Android. This is the static type. So static type is Android over here. All right, so this is the static type. And also we got dynamic type over here, Samsung. That's the dynamic type. Samsung. Dynamic type. Now, given these two classes, we can somehow partition the entire hierarchy into several categories. Okay, let's see. Let's start with something simple. Number one, I want to talk about the category of classes in the hierarchy that will allow you to do a cast without any compilation error. That's what I meant by compilable cast. Okay? And this one here, just remember, you can either do upward cast or downward cast. At this point, only the static type matters. Okay? Only the static type matters. So you can see here, we can either do upward casting. So you can see static type is exactly here. This would be the upward casting. Upward cast. Meaning that you can cast my phone up to smartphone if you want to. Of course, you can cast to itself, but it's not very useful. But of course, you can cast it to some parent class. That will be compilable, right? That's upward cast. There is another part of the category which would be downward casting, which would be basically over here. Okay, this part. Oh, let me try again. Okay, awesome. You can see itself and all the children, right? This will be downward cast. Right, let me recap what we have seen so far. Given the static type of the reference variable, you can either upward cast to all the ancestor, in this case, just one class, okay? Or you can downward cast to any of the descendant classes. You got so many, okay? We're only talking about compilation. Out of those cast that will be compilable, some of them might run into class cast exception. Can you guys tell me where they are? Basically, class cast exception will be those classes which cannot be fulfilled by the current dynamic type of the reference variable. And you can see the current dynamic type is Samsung. What are the classes that cannot be fulfilled by Samsung? Yes, go ahead, please. Yeah, this one here, right? So these are like a strict children, yeah. This one here, right? Exactly. Or put it another way. It cannot be fulfilled by dynamic type as long as it is not its ancestor. Okay? So let me now get it. So that will be orange. Sorry, let me just use another color here. How about this one here? These guys over here, the pink one, okay? Including the child classes of the dynamic type and also some other classes which are simply not the ancestor classes of the dynamic type. So these are the classes where you can cast without any compilation error, but at the runtime, you're going to run into class cast exception because they cannot fulfill the expectation of the dynamic type. I'll write it down, and then there'll be one more category to talk about, the pink, all right? So the pink one here will be compiles, compilable casts, but class cast exception at runtime. All right, are we okay so far? All right, one more. What about these guys? Well, these guys are straightforward because any one of these are neither ancestor nor descendants. If you try to cast them into this type, you will run into compilation error. Okay? I'll write down some line you can definitely try on the Eclipse. Okay? Okay, so here, so these are neither ancestor nor descendants. Non-compilable cast. Right, over here. Okay, and you can definitely try. So for example, if you try, let's say, given my phone over here, if you say, if you try this one here, let's say, let me just write it down. If you try to cast my phone over here into iOS, for example, just try this one here, just anonymous cast. You're going to run into compilation error. Okay, I'll leave you to try. Guys, are we okay about the generalization? About the class cast exception? The class exception occurs when you actually try to cast your variable into, for example, a class, let's say this. But the actual dynamic type cannot fulfill its expectation. That's a class cast exception. For Android, it's a descendant of Android. You mean descendant of Samsung? Right, let's say if you try to cast into this class over here, this is a child class of that. Potentially, it might have more methods to expect. That's why that cannot fulfill the expectation of this. No, no, you're getting that wrong. So you want to worry about, if I want to cast, let's say, let me put it down. If I try to cast, for example, my phone, let me just give you one example here. If I try to cast that into, for example, let's say Galaxy S21. Let's say that's a cast, right? There's my phone here. Dynamically, it's pointing to Samsung. And you're trying to cast that into Galaxy S21 so that you can call upon this alias any expected methods on this particular class. But you cannot, because this class over here cannot fulfill its expectation here. You cannot. Right? Just get the direction right. Okay? All right, guys, any part you want more explanation, I think this page here really summarizes what we have talked about so far. Right? You got expectation, you got static type, you got dynamic type, you got cast, you got class cast exception. So many things that we put together. There's only one more complication we have to add, which is about how you can check the dynamic type so it can be free as much, well, I should say you can minimize the encounter into class cast exception. Okay, we okay, right? Okay, but think about the issue here. I think this is not just applicable to this course. OOP definitely has a big part about inheritance. You want to make sure you get very clear about all the ideas we talk about that will lead you a long way beyond this course. All right? Take advantage of the moment to study that. All right, so we are good, and we can do some exercise before we take a break. All right, so there is one document here which I mentioned in my earlier announcement. I'll show you where you can find it. Go to the lectures page, And then you will see under the inheritance lecture, there is one reading here. If you click on that, and that document about 5 pages, it's not very long. So that one there really talks about the whole story about static type, dynamic type, expectation, class cast exception. So that will help. Okay, so why don't we do one exercise together? Okay, I will show you some slides, and then, if you can, grab a piece of paper. I think this will also help you. Okay. Number 1, given the class declaration like this, can you draw the corresponding inheritance hierarchy diagram? This will be something you will be expected to do in the test and the exam. All right, do that first, and then we'll give you other tasks. And the direction of arrow is very important, of course. Okay, another 10 seconds. Okay, and then I'll reveal the answer to you. But, of course, if you can think in your head about what it should look like, that's fine too. All right? All right, let's now see the answer. All right, that should be the diagram. All right, hopefully you got it right. All right, very quickly. You draw A first, and then B extends A. C extends B. And also D extends A, right? Straightforward. All right. Now we have the hierarchy. Let's now consider these 2 lines. I want you guys to think about whether or not each line should compile or not. Let's only talk about compilation. Okay? One thing to know as well, you can see this example here is rather symbolic. We got A, B, C, D, as opposed to iPhone, iOS, or resident students. This will be something you will see in the written test and the exam. You want to really be mechanical about checking these rules. Okay, what about line number 1? Is line number 1 going to compile? Yes. C here, well, dynamic type is C here, and then we are trying to assign to B, right? C is a descending class of B, right? That's fine. Hopefully that's something you can see. This one is fine. What about number 2? We're trying to do some typecast, right? And if you, of course, you can maybe after some study, just remember this diagram here. That should really help you a lot. Let's see what's going on here. We have static type B, and also we got dynamic type C. And we are trying to cast into D. Can we simply cast from static type B to D? We cannot. It's neither an upward cast or a downward cast, neither. So it's not good. So this line here is not going to compile. Non-compilable. Yes. All right. Now consider this line. We have B here, right? With a static type B. First of all, can I cast into A? I can. It's an upward cast. And then I know that this particular cast expression has the static type A. Now that I got A, can I do another cast? See what I'm doing here? I try to cast B upwards to A, first of all, by doing this cast. And then what I try to do is I try to cast the whole thing, which is of static type A, down to D. Basically, what I'm doing is, in order to go from B to D, I go to A first and go down to D first, and then go down to D. Every step I'm doing here is actually valid. I do an upward cast into A first. Whatever the result is, I go downward cast to D. So this is actually compilable. All right? You know what the consequence of this is? This means in Java, given two arbitrary classes, which has nothing to do with each other, we can always cast from one to the other. How? We need something that's similar to the row of A, so that we can go all the way up to somewhere, and then go all the way down to the target class. Is there such a class in general, Ferris? Exactly. So guys, this is a very important exercise. That's why I want to show to you. We're only talking about compilation. We haven't spoken about class cast exception just yet, all right? So the consequence of this is, given any two classes, let's say any two classes, let's say X and Y, you can always cast from X to Y. Okay, let's say this. For example, let's say for X, you have a variable called X, let's say little a. And you have a Y or little b for the variable. Okay? How do you cast from one to another? You can always cast from A into objects. Pretty much like how we cast from B upward to the top of the hierarchy. Because we know object is always the top of the hierarchy in Java by definition. All right? And once we get to the top, we can downward cast to the target, because it's guaranteed any class is a descendant of the objects. All right? And then once we have done this, we can definitely do another one, which would be to Y. That's how we do it. By the way, so this is definitely on your slides, and this one here, I will encourage you to try. All right? That's actually, in order for you to appreciate what's really happening in Java, right? You want to know how to do that. Okay? That's only about compilation. But there's a danger to it. Whenever you have the flexibility of doing something freely, you got to take consequence if anything goes wrong at the runtime. In this case, you got to watch out for class cast exception. Okay? Let's go back to this example over here. We said that I can cast from B to A and A to D. That's a way to fool the compiler. But what if I try to execute this? Am I run into any trouble? It turns out I'm going to run into trouble. All right, let's take a look. So let's say here, for this particular one, we know that it compiles, but what about at the runtime? At the runtime, this part here, when you're trying to cast B, which is B over here, to A, this part here is actually fine. It's only upward cast, right? So this part here is fine. This part here is no class cast exception. I'll say CCE. You'll know what I mean. All right? But for the second part, we might have trouble. For the second part over here. This part over here is going to give us class cast exception, because the actual dynamic type of B, right, is actually C. Can C fulfill the expectation of D? It will only be able to fulfill if C was a descendant class of D, but it was not. So we're going to write into class cast exception. Right? You can see it's a little exercise just to make sure you understand what you learned before. Class cast exception because dynamic type of B, which is C, is not a descendant of the cast type. In this case, D. Okay, very quick recap about what we learned from this example. Number one, given class declarations, maybe sometimes with some method declaration, that's something I'll give you to practice for written test number 3. Given class declaration, you should be able to draw the corresponding hierarchy for sure. And given lines like these, you should be able to judge whether they will compile. And in order to really cast from one class to another that seem to be not relevant to each other, you can do it just by casting all the way up to the root of the hierarchy. In this case, we got A, so we don't need to cast to objects. And then downward cast to the target type. As far as compilation is concerned, it's fine, meaning that you can still execute the code. But you're going to run into trouble when you actually run into class cast exception for the same reason, because the dynamic type simply cannot fulfill the expectation of the cast type as a target. All right? Any question about this? I hope the flow is clear. By the recording is there, you definitely have to review certain parts. If you need it, watch the recording or come to me. Inheritance, as I said in the beginning, it's a kind of coherent topic. You got many things that will get connected together. So you want to make sure every part is intuitive to you. Okay? Okay, final call. Are you guys okay? I really want to make sure you guys are okay. All right? Maybe at least for now. Okay? Alrighty, so before I talk about instance of, why don't we take attendance quickly by giving you guys some credits, and then we'll talk about instance of. Okay. Yeah, just get your mobile device or your laptop ready, and I'm going to start a class. After attendance, we can take a few minutes break, and then we'll resume. All right. Yeah, guys, you can check in. Yeah, if you got any trouble doing it, just come over to the front, and we got a sign-up sheet for you. Everybody's okay? All right. Good. Yeah, I'm gonna stop it over here. Yeah, guys, it's now 9:04. Why don't we take a 4 minutes break? It's okay. So 9:08. Okay, take a break. After break, we're gonna talk about more. Got some trouble? Okay, sure.
Just showed up and gave me like the thing.
Oh, okay. That's okay. That's okay. Just find your name, sort it by last name, and then put a check mark and put your signature. That'll be enough. Yeah.
Just sign my name, right?
I just signed here. Yeah.
All right.
Yes. Yeah. Oh, that's you? Okay. Can you just put a check mark here?
Oh, sorry.
Thank you. Awesome.
When I pressed answer, it immediately ended.
No, that's okay. Just find your name and then. Oh, you too? Okay, go ahead. Awesome. Yeah, guys, 2 minutes, and then we'll resume. Okay, 1 more minute, and then we'll resume. All right, let's come back to the discussion. Okay, and one more thing, actually 3 more things about inheritance, but we'll get to one that's a little bit new. Okay, so this one here is about basically. Okay, let me just tell you. If you just remind yourself about what we did a little bit earlier over here, and I was talking about whether or not the class cast exception may occur at the runtime depends on whether or not the dynamic type can fulfill the expectation of the cast type, right? That's all we said. As a programmer, Java provides an operator for you to check this. That's called instanceof, right? Let's now learn how to do it. It's pretty straightforward, but I want you to make sure you understand how to connect this with the story that we just covered before the break. And to make it maybe more intuitive, I would suggest this. For now, just ignore these 2 lines for now. Okay? What we want to do now is to think about line number 1, line number 3, and line number 4. What's going to be the consequence of executing these 3 lines? I need some volunteer to tell me. The question is simple. Are we going to get any compilation error? If yes, why? If no, what's going to be the output from this program? Okay, stare at that for 1 minute, and then we'll get into it. Yes, I'll point to Ferris for sure. Okay. Ferris, lighten us. I like it, but why?
When you try to assign students on the second one, the dynamic type non-resident student does not fulfill resident student.
Yes, very good, very good. So Ferris, just a little minor correction, if I may. So when you say, we would say Jim is cast to this type. You wouldn't say Jim is assigned to this type. Just be careful. Okay, good. Yeah, we're going to get a class cast exception. Okay, so at this point, Jim, at this point over here, you can look at Jim has the static type students and also has the dynamic type non-resident students. So if you try the diagram as before, static type is students over here. And also we got dynamic type, non-resident students. And what we are trying to cast the reference variable into is resident students over here, which is exactly here. Number 1, this cast over here is going to compile because by casting from students down to resident students, it's okay. It's a downward cast. As far as compilation is concerned, it's a compilable cast. However, at the runtime, can non-resident students, the dynamic type, fulfill the cast type resident student? It cannot. It can only do if if this is a descending class of that. Right? So it's not. Very good. If you already got this part, that's good. Class cast exception, because dynamic type non-resident students not descendants of resident students. There are 2 ways to interpret this. Number 1, it's not a descendant. Number 2, dynamic type non-resident students cannot fulfill. I'll write both. Expectations of the class type, which is resident student, right? There are two ways. So here comes the motivation for having such a new operator. Every time before you actually try to do some typecast, it is highly recommended you try to check to see whether the current dynamic type of the reference variable you're trying to cast, can its dynamic type really fulfill the type you're trying to cast into? You can let the runtime check do that for you. So this is why we got this part over here. Right, let's take a look at that. This one here is an if statement. And we have the operator called instanceof. So there's a new keyword you will have to learn. Instanceof, a single word. Okay? And there are two parts. You can think about it more like a binary operator. It has two operands. Okay? And on the left-hand side, usually will just be a variable, reference variable. In general, it could be also maybe some dot notation. For example, I can say maybe Jin dot maybe spouse. Right? Remember, the person class actually got a spouse attributes, which is another person. So that's also possible. Right? So the left-hand side is simply some reference variable you would like to check about its dynamic type. What about the right-hand side? The right-hand side is always a class name. A class name. And what does the instanceof operator do? It does exactly what we're expecting it. It checks to see whether the dynamic type of Jin at this point of check can fulfill this class type. If it can, positive, true. If it cannot, negative, it would be false. So in this case, is it going to return true or false? False, actually, because Jim's dynamic type is here, which cannot fulfill this class type over here. So that means it's going to evaluate to false. So overall, it's going to return false because non-resident students, the dynamic type, not descendants of the class type resident student. And if this part over here is actually false, that means we're going to bypass whatever that's inside. We wouldn't do the cast. So we effectively prevent the class cast exception from happening. Okay? That's really how you should understand why we need this operator. The class cast exception prevented. Because this expression over here returns false. But if you didn't really have this expression over here, without it, you would just run into class cast exception. All right? Guys, any question about this? We'll do some little bit of like an intensive exercise on instanceof, so you get a feel. But we'll get to that. Before that, any question about this? Okay? Let me just summarize one more time. Right? It's really important, so why don't we spend the time? Basically, instanceof is an operator, and the left-hand side, and also the right-hand side. The left-hand side usually is referring to some objects. Some objects. The right-hand side is actually some class, usually. Okay? And then the whole thing is going to be a Boolean expression. It's a Boolean expression, true or false. Okay? It's going to return true if. Two ways to look at that. Number one, the dynamic type of obj, some reference variable, is a descendant of the class. Right? So these are the two things, like a placeholder. The objects over here and also the class over here. That's one way to look at it. That's exactly what Java Runtime checks for you, all right? Of course, that's also how you judge to see whether class cast exception should occur before today's lecture, okay? And another way to look at that, that's equivalent, would be true if the dynamic type of the objects can fulfill the expectation of the class. Okay, so one more thing to say. Usually, this class will be used subsequently to do the cast. Subsequently to do a cast like this. OBJ cast to the class. That's why we are checking. And quick example. If you look at that, my goal is to really try to cast Jin into resident students. Before I do that, I want to know if Jin can fulfill the expectation of resident students. Right? That's the pattern. Okay. All right. Any question about this? Let's do the exercise. This one here, by the way, this one here is also on your slides, and that one I can leave you for affirming yourself. Right? That's the one we just talked about. And this is the example. The second one, I don't need to go over again, but it's very similar. Okay, you guys can do this. Let's go into the more interesting exercise. Okay. This one here, exercise for you. Okay. And this one here, maybe I'll treat that as maybe more like a summary, maybe recap for next time. We don't need to do that for now. That's it for now. Here. Okay, I'll give you guys time to think about. This is the given class hierarchy over here. Okay. We have my phone, static type, and the current dynamic type. We got a list of instance of expressions. Each one of them either return true, well, I shouldn't say return, sorry. Each one of them will evaluate to either true or false. For now, we just print the result out. But, of course, we can put that into some if expression as well. But let's say for now, just print out. I want you to think for each one of them is going to be true or false. Why don't you guys stare at this for 2 minutes and think about the answer. Of course, if you want to look at the box for hints, feel free. It's there for you. A common misconception is sometimes students might say, oh, so this one here is going to maybe evaluate to some class cast exception. That's totally wrong. The reason for using the instance of operator is to really prevent the class cast exception from happening, right? So there's no cast over here. We're just checking. Okay, another minute, and then we can go over the answer. Okay, 20 seconds. And then we'll go over the answer. All right, let's go over. Let's visualize what's happening here. For my phone, smartphone is the static type. This is the static type over here. And also we got Samsung is the dynamic type. Okay? And for instance of evaluation, we do not look at the static type. We only try to check whether the dynamic type for the variable at the moment of checking can fulfill this type over here. As long as the dynamic type is a descendant class of this, it will be true. Otherwise, false. Okay? So we only need to look at Samsung over here. So static type is not so relevant at this point. Let me wipe it out. Let's do one by one. For the first one here, is it going to be true or false? Can Samsung fulfill expectation of Android? Indeed, it's a descendant class, right? Good, it's true. What about Samsung itself? Of course, a class, it's a descendant itself. That's also true. Can Samsung fulfill Galaxy S21? No, it cannot, because this is not a descendant. Because this is not a descendant class of that, right? This will be false, but I'll write it down just for this one here, because dynamic type of my phone, which is Samsung, not descendants of Galaxy S21, all right? And what about iOS? Obviously not, right? It should be false, because how can Samsung fulfill iOS? It's neither ancestor. This is definitely not a descendants of that. Okay, so also false. What about iPhone 13 Pro? Obviously false. All right. All right. Hopefully, you got more intuition about what instance of is doing, right? You can think about whether it's going to be true or false. Usually, you will wrap the instance of operation in an if statement. And then inside the if statement, you will try to do some typecast. You want to check to see whether the typecast is safe before you actually do it. That's what the instance of operator is for. Okay. Okay. And this one here is the next slides. Let's take a look. You can see here, again, similar. You can see Samsung over here is still the dynamic type. Let's see what this one is trying to say. Samsung is over here, dynamic type. Okay? And you can see what we intend to do over here is try to do my phone, trying to cast that into Samsung. We should be able to do it, right? And my phone instance of Samsung, what would be checked? My phone has that dynamic type Samsung. Can it fulfill expectation of Samsung itself? For sure. So this cast will be done successfully. So this cast will be done. Done without class cast exception. That's good. What about the second one? If you look at the second one here, if you look at Galaxy S21 Plus, that one there, if you try to cast directly, would give you a class cast exception. But this will be your safeguard over here. And this expression over here is going to evaluate to false, because my phone, the dynamic type, Samsung, cannot fulfill its descendant class. So that's why it will be false. So you will not reach this line. Okay? So let me make a note over here. Cast not reached, because the instance of evaluate to false. The instance of evaluates to false. Similar, if I try to cast my phone into Huawei, this type over here, if I try to do it directly, it will be a class cast exception. Agree? From here to here. Neither ancestor nor descendants. So, sorry, let me say it again. From here to here, first of all, it's going to compile, because I'm downward cast from smartphone, the static type, down to over here. But it's going to be a class cast exception, because Samsung dynamic type cannot fulfill this Huawei. So I do this instance of check, which is going to evaluate to false. That's how I prevent it. All right? This one here is also going to evaluate to false. Okay, I believe that's about the instance of I want to talk about. Okay? It's a very nice operator for you to actually use whenever you're not too sure whether at this point I can really do the typecast, of course. Keeping track of dynamic type in general is very difficult, even for programmer. So I would say know that operator. So definitely will be useful when you need it. You might find it useful in your lab number 4, maybe. Okay, any question about this? All right? If you're okay with this, okay, that's what we just talked about for the evaluation result for instance of, and this is the one about how to use it. And just a very quick example quickly. Okay. And then we can move on to some other subjects. We still have some time, which is good. Okay? Okay, this will be the final bits to really go over, but nothing new. I'm going to compare 4 different scenarios. Number 1, number 2, number 3, number 4. All right? Let's take a look. What's happening here? And of course, you can look at the detail also on the slides, but I'll try to present in a way you will see what's really to be learned. I'm declaring some reference variable over here. You can see the static type, smartphone. Okay? Smartphone over here, static type. Okay? Dynamic type, iPhone 13 Pro. iPhone 13 Pro. Okay? What about the second example? For the second example, the dynamic type is the same. Still iPhone 13 Pro. The static type is a little bit different. iOS, which is over here. Oh, let me do a little bit better. This is still okay, right? Because iPhone 13 Pro is a descending class of that. So it's still fine. Number 3, I still have the same dynamic type, which is here. And then what about the static type? The static type is just the class itself. Okay? So it will be just like that, the same. And this will be fine too, right? Because this dynamic type is a descending class of iPhone 13 Pro. That's also fine. We got 1, 2, 3. 3 scenario over here. Different static type, but the same dynamic type, iPhone 13 Pro. Now, what we want to observe is to see what kind of methods can we call upon the myphone, the SP reference variable. Am I correct to say, given that iPhone 13 Pro, iPhone 13 Pro, and iPhone 13 Pro, we are really pointing to the same objects. So that means the range of expectation we can have on the reference variable here will be the same in all the 3 scenarios. Is it correct to say that? So what I'm just said was, given that dynamic type are the same, the range of expectations will be the same. Is that correct or not? What about the first one here? Given that dynamic type is iPhone 13, am I allowed to actually call upon dial, FaceTime, and QuickTake? And QuickTake indeed is an iPhone 13 Pro method. If you find yourself confused, it may not be a bad sign. That means you're still thinking, try to put things together, right? So now, let's go one by one. Should this compile? Just the first one. That one should. How about FaceTime? Yes, because it's iPhone 13 Pro. And how about this one here? Maybe yes, because it's iPhone 13 Pro. Any objection? If you thought that would be the case, guys, you need to study a little bit more, okay? I deliberately try to mislead you, okay? Here, we talk about what methods that might be called upon, the reference variable. That's about expectation. Remember, whenever we talk about expectation, only look at the static type. Dynamic type over here is not relevant at this point. All right? If that's still not really programmed into your mind, try to do that as soon as you can. Right? It's okay to not to exactly get it in the lecture, but you want to get it soon. Okay? All right, so that's why this will be the result. Okay? So let's take a look. If you look at SP, SP, SP here, the context objects, the static type is smartphone. That means the range of expectation you can have on SP is restricted to just the smartphone, which got dial and surf web, only these two. So when you, even though dynamically it is really pointing to iPhone 13 Pro, you still cannot access that. No, you cannot, unless you do some cast, right? That's kind of the story we talked about before. All right, that's the first scenario. And second one, hopefully you get a little bit better, right? How about this? I change the static type over here, iOS. Dynamically, it's still pointing to iPhone 13 Pro. Guys, can you tell me 1, 2, 3? Should one compile? Still, good, very good, I agree. Thank you. Now, in the previous case, FaceTime is not good. How about now? Because, Marcus? iOS, exactly. Exactly, change to iOS. iOS has a FaceTime. That's exactly right. Let me just point it out. Static type is iOS. So that's why you cannot do it. But can I do quick take? I cannot, because iOS at this point still cannot really support quick take. It's in a descending class. All right? All right. Final one. How about iPhone 13 Pro? Well, in this case, awesome, because static type simply matches the dynamic type. In that way, everything is possible, right? So dial, FaceTime, quick take, all of them are fine. Okay, but one thing you should really note, all these are just allowed by the static type, right? Just emphasize, you only look at the static type when you talk about compilation. But if you want to judge to see whether there's any class cast exception, you want to look at dynamic type, right? That's why things can get a little bit tricky when you first started to learn. All right, final exercise we can do together. I'll show you the solution right away, but let's say in this case, we know that given the declared static type is actually smartphone, we can only call upon expectation that's defined on the smartphone. But we know that it's really pointing to iPhone 13 Pro. So that means we can do a cast, right? And the next page shows to you what you can do over here. All right, let's look at the first one. This one here is anonymous cast. All right, let's try to see what it is trying to do. This part over here is the cast. Okay, so this part here is creating an alias of static type iPhone 13 Pro. Once you have done that, you will be able to call upon dial, FaceTime, and quick take, because now the cast type over here is iPhone 13 Pro, right? This is the cast type. Cast type. And whenever you're doing cast, you want to worry about whether or not there will be some class cast exception. Are we going to write into class cast exception? Marcus, why not? Exactly. Yeah. Very good. Absolutely. Thank you. This will be dynamic type. And this is iPhone 13 Pro is the cast type. Oops, sorry. This will be the cast type. And since we know a descendants of, it is true. That means no class cast exception. All right? You see, we have done this kind of mechanical check for many times. That's something you really want to make sure you're feeling comfortable about them. Okay. All right, we're done with this. Okay. I think we just got one more. Okay, this one here is just another example, just about doing anonymous cast. And we just go back to the student example over here. And all you want to, I just want to remind you quickly, and you can definitely review that on your own. When here, we are trying to do some cast. Okay? So this is students. S over here is the students. That's the static type. And we are trying to cast that into resident students. That's a cast type. Resident students. Resident students, that's the cast type. And this is a static type. What about the dynamic type? You can see dynamic type is exactly over here, right? Dynamic type over here. Are we going to run into class cast exception? The answer is we might, right? If we simply do this cast, we will run into class cast exception because dynamic type, non-resident student cannot fulfill this resident students. So that's why we do some instance of check over here. And can the dynamic type non-resident students fulfill resident students? It cannot. So that's why it's going to return false. You're going to evaluate to false. Which one? Resident students. Let me see. Okay, good. Yeah. That's awesome. How about this? Let's just change this example a bit. Non-resident students. So you got two examples. Non-resident students. And, yep, absolutely. So now the example in the slides is slightly different. So this one here, you can see dynamic type over here cannot fulfill this. But we are not going to run into class cast exception because this part here is simply going to evaluate false. Right? Good. Okay, this part over here is going to evaluate to false. So this part over here will be bypassed. Okay? All right, any question about this? Okay, let's see. We got about 10 minutes. I think we're definitely good to talk about a little bit of the next topic. But let's see what about the slides. Right, this part here, we have talked about the 3 scenarios, okay, or the 4. And this is also something we just talked about, right? All right. Guys, any questions up to now? All right, we're good, right? We got 2 more topics about inheritance. I can start with the first one, and then we definitely finish the second one as well in the first half of Wednesday. We need to talk about inheritance in the context of method parameters and also return types. So these are the 2 more things we want to talk about. But if you have already thought through about the issues of what we have covered, these 2 are not really surprising. They are more like a consequence of what we have seen. But let's start with something small and slow. We got 10 minutes. We'll see how much we can do. Okay. Student management system, right? If you go back about 4 or 5 lectures away before. So that's really the initial system that we want to build, right, from the problem. Student management system. Now, given that we have an inheritance hierarchy students, and we learn about all the rules about typecasting, about expectation, and etc. So now, let's say we declare an array. And every element in the array has the type students. And we call that student SS, right? That's a very important declaration to actually understand thoroughly. That's something we'll do today, okay? Okay, what I will do is I'm going to go over some code over here together with you, and we got 3 questions to go over, okay? We got student management system, a class, a new class, and don't forget we got a student hierarchy over here. Student, resident students, and non-resident students. So whenever you see this line here, okay, so the student over here, there are 2 things you want to watch out for. number one, it has an associated okay, let me just spell it correctly. Associated inheritance hierarchy. Inheritance hierarchy, which is here, right? You got student, resident student, and non-resident student. And number two, which is what we know before we even talk about inheritance. Whenever you declare an array of certain type, that tells you every member in the array is of this particular type. That's declared. So that means it's a static type, right? So number two, each elements in the array has declared type or static type, declared type students. All right, so these are the 2 points you can observe right away. Number one and number two. Okay? And what we want to do now is to declare some mutators to help us manage the student objects. We got 3 here. Add resident students, add non-resident students, and also add students, right? And the parameter type are different. That's why it's called polymorphic, right? Resident students, non-resident student, and students. Okay, we'll make sure we understand this before we let you go today. Well, only 7 minutes. That should be enough. Let's look at just this. Oh, before that, can we answer question 1 first? What would be the static type for every element in the array? Students, thank you. Just because of this decoration. That's easy, okay? Students. Thank you. That one's easy. Just look at here. Now, let's look at question number 2. And I'll let you think a little bit. If we look at this method here, and then we want to ask whether or not this line is going to compile. I'll highlight it for you. Well, it's an array indexing operation with some variable assignments. Is this line, which I just highlighted as orange, going to compile? If so, why? I'll give you a little bit of hints. In order to judge whether a variable assignment should compile, you should look at the static type of the right-hand side. Look at the static type of the left-hand side, and then you do the rule, right? Yeah, I'll point to you in just a moment. Navi, you want to talk? Oh, you're fine, right? Okay, that's okay. You're still thinking. Yes, go ahead, please. Mm-hmm. Okay, you're actually quite right about it. Okay, sure. Okay, so if you look at that, okay. RS over here will be its static type. How do you know? Static type is, I agree, Marcus, it's resident student, but how did you figure? We need to know where is the source. Declaration here, exactly. This is where the parameter variable was declared, number 1, okay? What about the static type for this? We just knew from the question 1, static type is students. And remember the rule of substitution. In order for this to be valid, this must be able to fulfill the expectation of this. So it's actually fine. And maybe just got the order wrong. Okay? Guys, are we okay so far, Valid because the static type of the right-hand side is a descendant of the static type of the left-hand side. Are we okay with this? We are only judging to see whether or not this line here will compile. All we got to do is to look at the relevant declaration, which will be here, and judge. All right? The next question is interesting. Okay? Let's say this. We're still talking about this method here, add RS. Let's assume we have already created some student management system objects. So it can be the context objects. So there's no null pointer exception, so don't worry. Okay? And when we call the add RS, we are passing some objects over here. The question is, under what circumstances can the following call be valid? Meaning that what should be the type of O? What should be the type of O? Basically, you were talking about calling a method with respect to its definition over here. We actually talk about something relevant to this before aggregation. Do you guys remember what it is? Starting with call. Call what? Call by value. I like it. All right? Guys, my hints to you. Think about call by value. So think about this is where we use the method, right? This is where we use the method. O over here will be the arguments. This is where we declare the method. And call by value actually does some implicit assignments. What was that? Was it RS is assigned to O? Well, O is assigned to RS. The order is really important. Okay, anybody remember? O assigned to RS? No, Ferris. The other way. That's okay. It was either one way or the other, right? So it should be the parameter is assigned to O. All right? So guys, I think for this part here, you may want to check on your call by value lecture, right? They are related. So this will be call by value. I know I got 1 minute, just bear with me. I'm going to finish this discussion, and then we can do an example next time. It's going to make sure we have RS, the parameter, is assigned to the O. You can see this part over here is the parameter, and this part over here is the arguments. And notice that we got into this variable assignment again. In order for this call by value, which boils down into a variable assignment, to be valid, what will be the requirements? The static type of the arguments, O, must be a descendant of the static type of the parameter. That's really the rule you should know. And the rule, somehow it looks like new, but it's not really new. It's based on two understandings. Number one, about the rule of substitution over here. Number two, about how you interpret call by value. Okay? I'll write it down, and then we are done. Just bear with me. So this one here, so for this particular assignments here, to be valid, the static type of arguments, O, should be a descendants. Descendants of parameter RS. RS versus O. Right, so that's the principle about polymorphic method parameter. And based on this, we will be able to have some very exciting array called polymorphic array. That's something we'll see on Wednesday. All right, guys, I think up to this point, we have covered basically every thing that you should know about inheritance. It's just two more applications. And I will release the practice question to you about written test number 3 after Wednesday's lecture. But for now, you can definitely start reviewing about everything about inheritance. Okay, I'll see you on Wednesday. Or tomorrow if you got a question about Lab 4. Take care.